The next speaker is Saskia Wessel. Saskia is Division Director at the Fraunhofer Institution for Battery Cell Production in Münster, and she will hold a speech or a presentation about really the core of from pilot line from lab to industrial production. Thank you very much, Saskia, and the stage is yours.
Good morning, everybody. I'm pleased to welcome you online today and to give you an insight into the research of Fraunhofer FFB. Yes, as Mr. Paulsen already mentioned, my name is Saskia Wessel. I'm the Division Director here in Münster for the Department Product and Production Technology. And together with my team, we built up here a research facility with a factory to enable innovations for the industry. And today I would like to give you some insights into the path at Fraunhofer FFB from lab to fab and how we implement innovations to industrial scale. A large number of pilot lines have existed in Europe for years. So here the Lee Planet network showed a roadmap of some pilot lines in Europe. So in some countries, pilot lines are already representing the battery cell production. And in the same time, large-scale factories are currently being built up in Europe. The factories are mostly being built with conventional plant and equipment technologies, while the innovative materials and processes are being developed in the research facilities. And that shows that here between the both worlds is a gap, and the Fraunhofer FFB was founded to close this gap between pilot lines on the one hand and industrial productions on the other hand, to enable innovation technologies from the lab to the large-scale production. The maturity of technologies can be defined by the TRL, the technology readiness level. While lab production tends to be in the lower TRL level, the large-scale production are on the higher TRL level. And the target of the Fraunhofer FFB is to map a range between a TRL 5 till 6 up to TRL 8 till 9, so that the technologies of different partners can be developed for industrial use. As we are showing here on the slide, we are working together with some partners to implement new technologies and innovations into the production line. For example, we are working in the field of new production processes together with the RWTH Aachen. We're in the field of new battery concept with the Fraunhofer Battery Alliance, and in regards to new active materials, for example, with the MEET here in Münster. The target of the Fraunhofer FFB is to enable the technologies from these partners for industrial applications on a large scale. At the beginning, the new technologies are further developed at the Fraunhofer FFB in so-called innovation spaces. Here we start, as I already mentioned, with a TRL 5 or 6, and the innovations or technologies can be operated in the innovation space totally on themselves regarding to the production line. So, for example, when we are developing a new drying process, we take the slurry from the production line, operating a new drying process, and then implement the dried electrodes into the cells from the production line. Therefore, a comparison between the technologies is possible between the conventional process in the production line and the new technology in the innovation space. When the technology is ready and fulfills the requirements of the production line, we integrate those technologies into the smallest production line at our equipment. Here we are operating with a TRL 6 or 7, and we validate the technologies in a running production process. When the process or technology is then ready, we optimize and implement it on a larger scale, and then we scale it up to the large scale of an industrial production to then run it in an industrial scale. So the Fraunhofer FFB maps the technological transfer and scaling process through diversified plant technologies. To reach this target and to develop those technologies step by step, we need, of course, a big infrastructure. Therefore, we built up some equipment here in Münster at different buildings. We are starting in the electrode field with the largest production scale with two production lines on the electrode manufacturing side. And then we have additionally one medium coater and dryer with a speed up to 30 meters per minute, and the smallest line which is running with 10 meters per minute. Additionally, we built up here three production lines for all three cell formats. On the one hand, the 21700 cylindrical cell, the pouch, and the prismatic cell. Theoretically, we could produce 7 gigawatt hours per year. This is the machinery capacity. But in realistic, we are operating this machinery totally different in comparison to the industry. For example, we will not producing in a 3-shift system. But for technologies and new innovative materials or processes or sensors, it could be possible to integrate the sensors or processes into the big scale and also validate it on a really industrial scale and also in a 24-hour system. Here we listed up some process parameters of our different machinery equipment in different buildings. So we start today with the FFB workspace. This is a building already built up here in Münster. We rent a room, a dry room, a clean room, and to build up some electrodes here at the space in Münster. Then the next building will be the FFB prefab. Here we scale up to a small production line. And here we are implementing the first innovations at Fraunhofer FFB. And then the large-scale production will be built up in a FFB fab. Here we integrate the biggest equipment of our infrastructure. And also here we are producing all the 3 different cell formats. But of course, however, the conventional battery cell production technology also have their disadvantages and challenges and offer great potential regarding cost and energy demand, particularly in Europe. For this reason, the Fraunhofer FFB is driving a technology change in the equipment concept. For this purpose, a heat map was drawn up, as already presented by Mr. Degen, in which the main cost drivers and battery production were identified. In addition to the dry coating process, I would now like to show you how technologies are developed at the FFB from lab to fab with the example of the alternative drying technologies. The motivation for us to look at the drying technologies is the high energy demand. As we showing here in this graphic, you see that the drying processes needs more than 40% of the total energy demand of a battery cell production. Next to the dry rooms is the most highest energy demand process. So we have a look on the new technologies, alternative technologies, drying technologies to decrease the energy demand for this process. Furthermore, the drying process needs a really long heating time to ramp up the dryers. So today we need more than 20 minutes to heat the dryers up to a process temperature up to 80 degrees. So we need a long ramp up time to running this process. And the last disadvantage of this conventional process is the very large footprint of the dryers. So today we need more than 40 seconds dwell time in the dryer. So we need more than 100 meters in length for the dryers. And this is a really big footprint in the cell factory, which we would like to decrease. So we started with a technology study for alternative drying technologies. Yeah, the technology study has a really wide range, but today I would like to have a focus on the main alternative technology alternatives. So this is the focus of the study. And as you can see, we compared different alternative drying technologies in regarding to heat conduction, electromagnetic waves, and heat flow. The convection drying, so the conventional process, is the heat flow. And we compared some other technologies regarding, for example, the conduction drying, induction drying, and also drying technologies with electromagnetic waves, for example, microwave drying, infrared drying, and laser drying. And at the result, we compared these technologies regarding the parameters development status, cost efficiency, process performance, and product quality. And here we benchmarked the technology alternatives. And as you can see, the laser drying and also the infrared drying are the most promising technologies for us to optimize the drying process. So the laser drying, for example, has a really low energy demand, also the infrared drying, and they have a really fast ramp-up time. When we compare those both technologies, with the infrared drying, we have an infrared emitter. This infrared emitter has electromagnetic waves in the near infrared range between 800 and 3000 nanometers. And yes, it's suitable for both anode and cathode applications and is already used in a serious production as a booster. So the technology is not ready to completely drying the electrode completely, but it's integrated in the conventional process to speed the process a little bit up. Then the laser drying, we are using a laser and an optic to heat the electrode up. Here we are working with a wavelength, for example, with 1070 nanometers. And this process technology is in research. It's not integrated in a production line today. So these both technologies are on a different TRL level, but have both advantages regarding the energy demand in a battery cell manufacturing regarding the drying process. Here we compared the both technologies regarding the defined parameters in the technology study. As I already mentioned, the development status on infrared drying is a little bit higher because it's already used as a booster in a production line. The laser drying is in a research and first prototypes. So here we have a lower TRL level. The infrared drying has the advantage that it's has a really low investment and really high energy cost efficiency. The laser drying has also really high energy cost efficiency, but the investment of the laser is a little bit higher than in comparison to the infrared drying. The process performance of both technologies are really high, so we can switch the dryer on, and then we have in a really short time the process temperature we would like to have. The laser has a little bit better in the process parameter accuracy, so we have a really precise energy input through the optics into the electrode in comparison to infrared drying, where we have more or less a bundling of the heat. Both technologies has more or less a good product quality at the end of the process, but there we are still in development to reach the same product quality, of course, in comparison to the conventional process. After the technology study, we decided at the Fraunhofer FFB that both technologies are really interesting for us to be integrated in our production line. So we started with two different projects. Of course, the infrared drying, as I already mentioned, has a higher technology level. So here we already integrated the infrared drying into it in our production line in the FFB workspace. This will be in the future also be the smallest production line at Fraunhofer FFB. So we integrated the infrared dryer here at the beginning, and we already have some results of the validation of this technology. So we reached a reduction of the energy up to 85%. We already could reduce the dwell time to 30 seconds. Regarding to the conventional process, there we are more or less one minute dwell time, and therefore we can also reduce the plant size of the equipment because we don't need a length of more than 100 meters of the dryer with a lower dwell time. And the last advantage of the process is the really short ramp-up time. So in comparison to the conventional dryer, you can see here in the picture, after the infrared drying, you need not 20 minutes to heat the production process up. We are more than in a few seconds, we are ready to dry the electrodes with the infrared drying process. So here with this technology, we would like to scale it up to a really higher production scale with more speed, then so that the infrared drying process can totally substitute the conventional drying process. With the laser drying, the TRL is lower, so here we are working together with some partners in the lab scale. So we implement the laser in the first step at the production site at RWTH. Here we can work with the coating speed up to 2 meters per minute. When this is ready, it will be integrated in a line at the Fraunhofer ILT. Also there, we have a small pilot line up to 10 meters per minute. And we hope that this technology can fulfill the requirements of a production line, and we will be successfully developing the laser drying into the production technology. So then we could integrate this technology into our line at our site, hopefully in 2 or 3 years. And here we can then implement it and validate technology up to 30 meters per minute, and then scale it up to the fast speed of the production or industrial scale. I hope I could give you some examples and approach and show you the approach at FFB, how we would like to scale innovative technologies up to industrial scale. And yes, thank you very much to our partners and also to our funding. And I hope you have some questions, and I'm looking forward for the discussion. Thank you very much.
Thank you, Saskia, for your nice presentation. Are there any questions out of the audience? Okay, I will start with one question. During our first session in the morning, we had quite a lot of questions regarding inspection technologies and the area of quality management. Do you see, or what ways of collaboration do you see in this area?
I showed some example of a production process and how we implement those innovative technologies in our production line. But of course, it's also you can also use it for new sensors. So we also integrate some sensors, innovative sensors, in our coating line in the workspace, and then validate those sensors in a really small scale. And when it's ready for and has the advantage we hope when we integrate those innovations, then we scale it up to the higher industrial scale. So of course, this approach is also usable for new sensors.
Okay, and another one, it is more like a more open questions. When you could do some kind of time traveling and move 10 years to the year 2032, where do you see the FFB in 10 years?
I hope you can see a total new production approach for battery cell manufacturing, so that we have a production with lower energy demand and higher cost efficiency. And that's, yeah, this is a total difference between the current production lines of the cell manufacturers in Europe. And of course, in 10 years, I also hope that some innovative technologies we implement in our production line are running in the industry, so that we also has reached the transfer from the lab to the industry. This would be my dream.
Okay, sounds like a very good dream. Okay, are there further questions? Does not look like this. So thank you, Saskia, again for your presentation and your deep insights regarding the drying projects currently running in the Fraunhofer FFB. Now I get information that there is a question. Okay, the question is, how are the skills from the employees? Do we have an appropriate program as example?
The competence of our team is very interdisciplinary. So we have some engineers, chemistry scientists, physical scientists. So we have a really interdisciplinary team here in Münster. And I think this is the most important when you would like to build up a cell manufacturing factory like this, that you integrate all the competences and all the disciplinaries you need for the production of battery cells.
Is there any apprentice program currently running? I guess that was the main question.
Yes, we have some training on the job already on the FFB workspace. This was one of the reasons why we built up very fast here at Münster and rented clean room and the first production processes of the cell manufacturing, electrode manufacturing. I think these are the most complex one, the mixing and the coating. When you're not able to produce electrodes, you don't have to produce cells. So this was the reason why we built up really, really early in our time here in Münster. And there we already train on the job for our technicals and also for our students, that they can see how the electrode manufacturing is working and also get a feeling for the materials and for the quality we have to reach when we would like to build up good cells, high quality cells. I hope this was the answer of the question.
If I got you right, it's like the more or less informal training on the job part to be on the machines and to learn it from scratch, and not like the official job training with, I don't know, the EHK or the, let's say, job training. Okay. Thank you very much, Saskia.
You're welcome.